Good morning, students. I am Pramod Joy, your computer science teacher. And today we are going to discuss about the Python libraries, our new topic. We already discussed the functions. Now it is Python libraries. This all comes under the main heading, unit number 1, computational thinking and programming. So shall we start? A library refers to a collection of modules that together cater to specific type of needs or applications. The act of partitioning a program into individual components is called modularity. The act of partitioning a program into individual components is called modularity. A Python module is a file containing variables, class definitions, statements, and functions related to a particular task. The Python modules that come preloaded with Pythons are called standard library modules. An example for a standard library module is math. A module in general is an independent grouping of code and data. It can be reused in other programs. It can depend on other modules. An example for a module is given below. The name of that module is temperature conversion. In that, two functions are written. One is to calculate that centigrade and the other one is to calculate the Fahrenheit. And how that file is created and below how that module is called. Please go through that. Some important points related with the Python libraries. It is explained with the help of examples. For example, the first point, help temperature conversion. Temperature conversion, we already discussed, it's a module which contains two functions. So when you enter help temperature conversion, it displays the module name, file name, function name, and if there is any constants, those constants also. Now dir, directory of temperature conversion. It gives you the names of all that is defined inside the module. Names of all. Now, suppose if the name of that module is little bit lengthy, you can give a different name to it, an alias. For example, import temperature conversion as TC. Now temperature conversion will be known by the name TC. For example, you don't want to import all the functions from that module called math. You want to import only one function called pi. So you can write like this: from math import pi. Or suppose that particular module, math module, contains many functions. Out of that, just 2 or 3 you want to import. So from math import sqrt square root comma power pow. Or if you want to import all the functions, from math import star, or just you can import math. That's also enough. Some string functions are explained in this slide. String functions like join, split, replace, etc. Join. Joins a string or character after each member of the string iterator. For example, asterisk within double quotes dot join of hello. So inside that hello, after each and every character, that asterisk will be there. Now the next one is split. Splits a string based on given string or character and returns a list containing split strings. For example, I love Python dot split. So it will print separately I, love and Python. Now to replace. Replaces a word or part of the string with another in the given string. For example, I love Python dot replace. Python should be replaced with programming. So it will be I love programming. Using random module. To use random number generators, you have to first import the module random using import command. Random function. It returns a random floating number n within the range 0.0 to 1.0. 1.0 excluded. Rand int function. It returns a random integer n in the range a comma b. Both a and b are included in that range. For example, import random, print random.random. So it will print any number in between 0.0 till 1, excluding 1.0. Print random.randint, random integer 15, 35. So in between 15 and 35, it will print any number, including 15 and 35. One more example. Print random.random multiplied by 35 minus 15 plus 15. So it will print any number in between 15 and 35. Creating a Python library in a directory structure in order for a folder containing different modules to be recognized as package, a separate file, namely _init_ must also be stored in the folder, even if that file is empty. Once you have your package directory ready, you can associate it with Python by attaching it to Python site package folder of current Python distribution in your computer. In order to check the path of that site packages folder of the Python, on the Python prompt, type the following two commands: import sys and print sys.path. Once you have figured out the site packages folder, the simplest way is to copy your own package folder and paste it in this folder, in the site package folder. Now it has become a Python library, so that now you can import its modules and use its functions. For example, I created a folder called eg1, example1, and inside that minimum I have to create two files. And the very first one, that's mandatory one, init. Maybe it's a blank file, it's an empty file. And the other one, my module, pgm1.py, since it's a Python related file. And that pgm1 contains a function called add1 to add two values. So after completing the entire pgm1 and eg1 example1, now what I have to do? I have to copy that eg1 example1 to that site packages folder. So how to get that site packages folder? You have to enter import sys and print sys.path. For example, in my case, the address is like this: C uses Pramod Anaconda 3 library site packages. So open the site packages and I have to copy that eg1 example1 into this particular folder. So I created a file called pgm1. In that I defined a function called add1. Later I imported that eg1.pgm1. eg1 is the folder name and pgm1 inside that. And a is equal to, a variable name a is equal to eg1.pgm1.add1 of 10. So what happens from that folder eg1, from that function pgm1, from that file pgm1, it will call that function add1, and one variable is entered through that while calling that function add1. A value 10 is entered, so it will print the value 20, because in that function it is written return 10 plus 10. Now print a, you will get the value 20.